All right, continuing 8.4 here, we're going to throw in our sum and difference of perfect cubes with some GCFs. So we have here, you notice that this is a cube, so it's tipping me off that it might be the sum or difference of cubes, but 24 isn't a cube. So let's see if we can take a 3 out of these because they're both divisible by 3. So I take a 3 out, and 3 goes in there 8 times, and that's times z cubed, plus, and 3 goes into 81 27 times. And look at that, sure enough, they're now cubes. So now I have a 2z as a cube root and a 3 here as a cube root. And so you don't want to forget your GCF, right? 3. And then I'm going to form a binomial with those cube roots, and then a trinomial with the first one squared. So square the 2, we get 4. Square the z, we get z squared. Product of these two, 3 times 2, which is 6, and those are z's. The last term is always positive, and that's 3 squared, so that's 9. And now the sign. So this positive here goes in here, and whatever that is, it's the opposite that goes in the trinomial. And there we go. There's our factored sum of 2 cubes. And next we're going to go down and we're going to look at this one. Okay, so the first thing that I'm going to notice is that there's no perfect cubes in the numbers, although the variables are perfect cubes. So with these, every once in a while you're going to run across where it's not going to be the GCF that pulls out and gives you the sum or difference of 2 perfect cubes. So I'm going to run through all the common factors here. So I've written out all the factors of these numbers. So one common factor is 2, and if I factor 2, I get a 24 and a 27. Well, you see the 27 is a perfect cube, but 24 isn't, so that's not what I'm looking for. They both have a 3 in common, so if I factor out a 3, 16 and 18, neither of them are perfect cubes, so I know that's not going to work. And then the GCF, which is 6, the GCF, which is 6, doesn't leave me perfect cubes either, and there are no other common factors here, and so that's just going to do it. We're going to write out 6 is our GCF. 6 goes into 48 8 times, so that's 8 x cubed, and then minus, and 6 goes into 54 9 times, and that's y cubed. And even though 8 is a perfect cube, 9 isn't, so this thing isn't going to factor any further, and that's going to be it. And sometimes that's the case. Sometimes they factor further, sometimes they don't after you take a GCF, and you just have to be aware that that happens, and you want to keep on your toes and always check, but never try to make it go further than it does. All right, now our next couple here, we have those higher exponents. So we can see that this is a perfect cube because we can divide it by 3. So the cube root of x to the 6th is x to the x squared, and the cube root of 125 is 5. So we have the sum of 2 perfect cubes. And so we're going to form a binomial with those cube roots, x squared and 5. And then we're going to square the first term. X squared squared, 2 times 2, power rule, right, is x to the 4th. Then the product of those, 5x squared, and then always a plus in the last one, 5 squared, which is 25. Then the signs come in, plus here, and then opposite over here. And that's it. That's our answer, and we're done. This is not going to factor. It's not the perfect square trinomial, and x squared plus 5, not going to factor. All right, going down here, x cubed, yep, that's going to give us an x, and y to the 6th, that's going to give us a y squared, and then 64, that's 4 to the 3rd power. So this is the difference of 2 perfect cubes. So we have perfect cube root minus the cube root, and then cube root squared, so x squared, and y squared squared, which is y to the 4th, then the product in the middle, which this one's going to be a plus, 4x y squared, and then always plus, and 4 squared, which is 16. And there we go. That's it. That's the final lot of it. Now, if it weren't for that x, we could possibly have factored that, but because the x is in there, that wouldn't factor further. But do look for that, because every once in a while this binomial will factor further, and a lot of times it will be as a difference of 2 perfect squares. So just be aware of it. All right, and when we come back, we're going to be doing your turn problems in this one example down here that really should have been a your turn.